By 2027, artificial intelligence could consume as much electricity as the entire nation of Japan. That's not science fiction. It's the next global crisis forming silently behind the AI boom. Everyone's racing to build smarter machines. But no one's asking the question that really matters. What happens when the grid can't keep up? AI was supposed to make the world more efficient. Instead, it's becoming one of the largest consumers of electricity in human history. The new bottleneck isn't data or chips, it's energy. And this crisis will determine who controls intelligence itself. Let's start with the math. A single AI training run for a frontier model like GPT-5 consumes roughly 1.5 to 2 gigawatt hours of power. That's the same as 150,000 US homes running for a full day. Globally, data centers now use 460 terawatt hours, TWh, annually. But with AI workloads doubling every 6 months, the International Energy Agency predicts this number will exceed $1,000 TWh by 2027, about 8% of the world's total power demand. To put that in perspective, that's double the consumption of the entire aviation industry. AI isn't digital anymore, it's industrial. Each AI factory, what we call a data center, consumes as much energy as a small steel plant. The new economic equation is simple. Every megawatt produces intelligence. The faster you can produce it, the more control you have. That's why countries like Norway, Iceland, and Sweden are suddenly becoming AI energy superpowers. They have cheap hydroelectric power and cold climates, which reduce cooling costs by up to 40%. Meanwhile, in the US, regions like Virginia and Texas are adding hundreds of megawatts of new capacity every quarter. It's a digital gold rush, powered by electricity. This shift is redrawing the global energy map. Saudi Arabia is building NEOM AI grid, powered by solar plus geothermal, worth over $50 billion USD. Microsoft signed a 20-year, $835 million nuclear deal at the 3 Mile Island site to power AI expansion. Amazon is testing SMRs, small modular reactors, for private data center grids. China plans to integrate AI demand into its 14th five-year energy plan, focusing on coal to hydrogen transitions to sustain compute growth. The future of AI isn't in Silicon Valley, it's in power valleys. Before the recent AI boom, the world's data centers already accounted for a significant portion of global electricity use, estimated at around 460 terawatt-hours per year, and are now being driven toward an exponential curve by generative AI. Every kilowatt that goes to AI must come from somewhere, and in many regions, that somewhere is already over capacity. In Ireland, data centers already consume 20% of the national grid. In Virginia, grid operators are warning of rolling constraints by 2026. In Amsterdam, permits for new data centers were suspended due to power shortages. The infrastructure we built for the digital world wasn't designed for this kind of load. AI is rewriting physics, faster than utilities can react. It's not just electricity. Cooling is the hidden drain of the AI revolution. A single hyperscale AI campus can consume 1 to 2 million gallons of water per day for cooling towers. In total, AI training could add an extra 300 billion gallons of water usage per year globally by 2027. In places like Arizona and Spain, this is already causing tension between agriculture and AI. The question is no longer, how fast can we train models? It's who gets the water. This conflict is already playing out in communities around the world. This tension exposes deep-seated inequalities in resource allocation. Ignoring this connection is not just irresponsible, it is a direct path toward ecological and social instability. Every revolution hits a wall, and for AI, that wall is power. When data centers draw too much, they trigger brownouts, forcing grid operators to choose, keep the lights on, or keep the servers online. Engineers at several major utilities, including ERCOT and PJM, have already issued warnings. AI growth will exceed grid expansion by 2027. That means we could face the first AI blackout. Not a failure of technology, but a shortage of power to run it. Imagine an AI outage where half the world's cloud infrastructure goes offline for hours. Not because of cyber attacks, but because we ran out of energy. During a heat wave or a cold snap, the grid could fail to meet the combined needs of homes and businesses, critical services, and data centers. Grid operators would face an impossible choice: to implement rolling blackouts or to risk a catastrophic, uncontrolled failure of the entire system. This is the new reality of the energy intelligence age, where the pursuit of artificial minds could lead to the lights going out in the physical world. Faced with the growing fragility of public grids and the fierce competition for energy, the world's largest technology companies are no longer content to be passive consumers of electricity. They are transforming into major players in the energy sector, taking control of their power supply chains to secure AI ambitions. This strategic pivot involves a multi-pronged approach: buying land near major power sources, signing massive long-term power purchase agreements, investing in private power generation, and microgrids. In 2024 alone, tech companies committed over $45 billion to energy infrastructure, more than some countries invest in an entire year. Microsoft, Google, Amazon, Meta, they're not just buying renewable energy credits, they're directly financing new solar farms, wind turbines, geothermal plants, self-contained networks that operate independently, keeping data centers powered if the main grid fails. They're investing in massive battery storage systems and exploring small modular nuclear reactors and nuclear fusion. The goal? Complete energy independence. Private, reliable, resilient power for AI factories. By building power empires, they create a parallel, privatized utility system. It's sensible for business, but it raises serious societal questions. As big tech siphons off energy and engineering talent to build private grids, what is left for the public? This growing divide could exacerbate inequality, leaving public systems more vulnerable and under-resourced, while the world's most powerful corporations secure their own energy futures. In the face of AI's enormous energy appetite, the instinctive response is to look to renewables. Solar, wind, clean, increasingly inexpensive, rapidly expanding. On the surface, they look ideal, but this view misses a core problem: intermittency. Solar panels only make power when the sun shines. Wind turbines only spin when the wind blows. AI runs 24/7, but renewables fluctuate hourly. That mismatch is the renewable paradox. Batteries can store excess from sunny or windy periods and discharge when production falls. But today's battery scale is far too small for projected terawatt-hour AI demand. Scaling storage needs huge mining and manufacturing, historic in scale. So the conversation is shifting to firm, carbon-free options. Nuclear power, steady 24/7 electricity, is seeing a renaissance driven by data center demand. Geothermal, tapping Earth's heat, is also rising as a steady source. Conclusion: an all-of-the-above approach. Renewables remain vital but must be paired with massive baseload build-out and energy storage to keep AI running. The collision course between AI's exponential growth and the physical limits of our energy infrastructure will define the remainder of this decade. Based on current trends and planned projects, we can make several bold and concrete predictions for the years ahead. These are not speculative fantasies, but logical extrapolations of the path we are on. By 2026, the global energy consumption of the AI sector is likely to surpass that of the entire aviation industry, marking a symbolic moment where digital activity becomes more energy-intensive than a major form of physical transportation. By 2027, we can anticipate the first instance of a nation-scale AI power shortfall. A country that has heavily courted data center investment may find itself in a position where it must choose between rationing electricity for its citizens and industries or curtailing the operations of its lucrative AI tenants. This event will send shockwaves through both the tech and energy industries, highlighting the stark trade-offs involved and likely leading to more stringent government regulation over data center development and energy allocation. By 2028, it is highly probable that a major technology company will announce the successful operation of its own private, grid-independent power source, likely a small modular reactor or an advanced geothermal plant. This will mark the culmination of the trend toward private energy empires, creating a new class of corporation that is fully vertically integrated from power generation to AI application. This move will grant that company an immense strategic advantage, but it will also deepen the divide between public and private infrastructure, raising profound questions about corporate power and sovereignty. By the end of the decade, in 2030, the AI industry's share of global electricity consumption could realistically reach or exceed 10%. At this point, electricity will be unambiguously understood as a primary geopolitical resource, where a nation's influence is measured not just in economic output or military strength, but in its capacity to generate surplus baseload power. Countries and corporations that control this power will control the development and deployment of the world's most advanced intelligent systems, creating a new global hierarchy defined by energy and computation. Those left behind will face a new form of digital and economic marginalization. We are entering the energy intelligence age, where economic power no longer depends on oil reserves, but on AI compute capacity. Electricity becomes the new GDP. Every terawatt produced equals influence, and every blackout becomes a global financial event. The countries that adapt their grids fastest will dominate this century. The ones that don't will fade into data poverty. AI began as a tool of knowledge. Now it's becoming a consumer of existence itself, pulling energy, water, and minerals into algorithms. The real question isn't how intelligent AI will become, but how much energy humanity is willing to give it. We thought AI was software. We were wrong. It's the largest industrial infrastructure shift since electricity itself. This is a societal conversation about priorities, values, the kind of future we want to build. Every megawatt hour that is directed to an AI data center is a megawatt hour that could have been used for something else, to power a hospital, irrigate a farm, light a school. We are trading tangible resources from the physical world for the outputs of a digital one. We have not yet had a public discussion about whether that trade is just or wise. The coming energy crisis is not merely a technical problem. It is a reflection of our values. Do we prioritize the creation of ever more powerful AI models over the ecological stability of our water systems? Do we accept a future where private corporations operate their own power grids while public infrastructure crumbles? The path we are on suggests a world where the benefits of AI accrue to the few who control the energy to run it, while the costs are socialized among the many who must deal with strained grids and depleted resources. We must move forward with a clear-eyed understanding of the true costs of this technology and build governance structures that ensure it serves the broad interests of humanity, not just the narrow interests of a powerful few. The ultimate question is not how smart our machines can become, but how wise we can be in their creation. How much of our world are we willing to feed to our machines? The next wars won't be fought over code or data, they'll be fought over energy. Follow MoneyGrid AI. Next week, we uncover how data became the new global currency and why control of information will soon replace control of oil.